Cool. So hopefully for those folks that have joined in the past, my name is Vidya Murthy. I serve as COO here at MedCrypt, which also happens to own the MedISAO. And we have started this educational series to talk more about software bill of materials and vulnerability lifecycle management in total. I'm joined today by my colleague, Joby. If you want to take a second to introduce yourself and tell the folks a little bit about you.
Hello, everybody. My name is Joby Nath. I'm officially a data analyst at MedCrypt here, but my specialty area is SBOMs, the regulations around them, generating the whole spiel. So I'm going to be chiming in and providing a little bit of extra information to today's webinar.
Yep. So Joby does a lot with customers on a day-to-day basis. So he has a lot of kind of real life anecdotes about what we see coming back from the FDA, as well as folks kind of anecdotal experience with various strategies out there when it comes to SBOM management. So we'll go ahead and hop right into it. Just logistically, again, the slides will be shared, a recording will be shared as well, and we'll send out an email with a few thoughts and a note after this completes, as well as links to the subsequent series to sign up for those. Cool. So one of the common anecdotes we hear from folks is, hey, we got our device, we got it to market, we got through the FDA, I have an SBOM, I'm done, right? Let me focus on the next clinical feature. Let me focus on the next thing my customer wants. And I think the reality of how vulnerability lifecycle management plays out is a bit different than the idea that you're one and done. As much as I would love for security to be one and done, and I'm sure most folks would, that's just not the way the world works right now, right? So that the generation of the SBOM is just the beginning. And it really, if you take a stance of not doing anything after it, you will very quickly become outdated in terms of vulnerability management, not meeting your FDA or customer expectations. You'll inevitably end up with a false sense of confidence and have a difficult time responding to requests. It seems like Christmas, there comes up a new vulnerability that everybody is impacted by, and we have to determine the path forward. And this would certainly put you in a posture where you wouldn't be able to answer that question as to whether you're impacted or not. And I think one of the hardest things is if you don't intentionally plan for ongoing SBOM management, it becomes significantly harder when there is a fire drill to know how to proceed.
Yeah, I actually like to use an analogy with self-driving cars. If you're not familiar with it, right? There's a lot of crazy things that cars can do on their own, but they haven't achieved complete automation. And in a lot of scenarios, if you don't have a driver at the wheel to react to stuff, or if you try and mix the two, have somebody driving and have the system be automated, you end up actually with a worst case scenario in some situations. And I like to tell people that when it comes to the SBOM space, it's mostly automated, which sounds good at first, but that can lead to a lot of issues with people assuming stuff is correct, or assuming stuff is going to be just, like you said, a press of a button. And it turns out to be way worse than that.
So what are the things that require us to update the SBOM? So imagine you've built your device, you've gotten it out into the field. When do we have to make SBOM updates? So imagine there are new software releases on an ongoing basis, whether they're for clinical functionality, operational functionality, security patches, whatever the case may be, right? Whenever there's an update or new release to your device, that's a time to have a new SBOM generated. And in all transparency, we understand that often devices are given to hospitals and updates are offered. Whether that update is applied to the device is actually harder to determine than one would hope. And so keeping track of the various versions that could be in the field if a hospital hasn't applied an update or has partially applied some, but not all of the updates, becomes a task as well. Obviously, if a new vulnerability is discovered, something new comes from it, or you've done some sort of remediation, having to consider that into the next version of the SBOM is there. Component changes, so you decide to migrate from using OpenSSL to WolfSSL, or something similar, right? You change a library that you're using, that would require a change to an SBOM. And then the last one, if you have components that are changing configurations or something to that effect, you might need to consider having an SBOM update them as well.
To add to that last part too, something people don't often consider is it's not just the vulnerabilities that might lead to a change in an SBOM. If your remediation changes, your solution to the problem changes, you may also need to update the SBOM as well, or the associated document with it to keep track of that.
Yeah. And I guess the definition of what do you do with an update is also something to maybe spend a minute on. The idea that you have to provide an SBOM to customers is certainly part of it. One of the bigger drivers is keeping your quality management system up to date and making sure you have the various versions that are applicable available and you have the documentation to support it. So like Joby alluded to, right, this idea of having remediation documentation isn't necessarily a change to your JSON file, right? Like it's not about what's actually in the SBOM. It's something related that you likely need to capture.
If I can also add one point too about the sharing SBOMs with customers. Um, Unless you have some contract that specifically tells you to share everything, we strongly recommend that you share the stuff that you know has been remediated and dealt with. Oftentimes when you're working with an SBOM and you're looking at, like say, a Windows device or a Linux device, there's going to be hundreds or potentially thousands of CVEs associated with those operating systems. Chances are you haven't dealt with all of them. And so when it's worth it to sometimes have two SBOMs, right? The internal one that's for your security team and for submitting to regulators like the FDA, and then the external one that you share with people, which is meant to, again, it provides them with valuable information, but you don't want to provide potential hackers or people who don't have good intentions with a roadmap to use at the same time, right? So
Yeah,
that's very important to keep track of.
the way you share is absolutely important, right? We're not suggesting that you publish it on your main domain website and make it available for public consumption. I think what Joey's trying to say is right size the ask from a customer to what it is that you're providing.
Yes.
Yeah. So I guess the task then, right, is making sure that you have an SBOM management process in place. One of the challenges with medical device product security in particular is you have so many various functions involved in getting a device to the field, right? You have your traditional engineers, you have an RAQA function, you have this corporate function often that's called product security. All three of them have to work in harmony to really not just have the SBOM at the time of generation, but ongoingly maintain it and make sure the folks that need to be involved in keeping it up to date are in the loop. So making sure there's a clear definition of who's responsible is critical. One of the common things when I worked for a device manufacturer was the folks working on a device. Once that version of the device is out, right, they move on to something else. They aren't just sitting there waiting to maintain that existing device. So that can make it sometimes harder to say, hey, somebody generate the next SBOM for this when nobody's actively working potentially on that device version. The next bit is around version control. Having a very clear way of versioning is critical. Anyone who spent time with the National Vulnerability Database and looked at how vulnerabilities are named and how they name components in there can very quickly see that inconsistencies cause a lot of issues. So your own versioning of how you name your SBOMs and keep track of changes becomes that much more critical. Having a workflow, making sure you have a timely solution to resolving SBOM challenges or findings is something that you'll have to also work through. And this can include not just, hey, we found a new vulnerability, we got to do something about it, but your ongoing standard software updates, right? Making sure that there's some build into your CI/CD pipeline potentially, or how your development team works will be important to make this a little bit easier to manage. And then the last bit that Joby referenced here, right? How you distribute the SBOMs becomes increasingly important, and making sure relevant stakeholders are getting it, right? And that can mean, to Joby's point, potentially having two versions of data that are shared, right? One that potentially has a bit more for your internal quality system and otherwise, or regulators, and one that includes kind of just the components that customers are asking for.
One thing too, I want to add when you talk about the workflow and specifically the timetable of stuff here. Something that a lot of people don't think about when they're coming up with these timelines, but ends up being really important once an exploit occurs, is your timeline to disclosure and patching those vulnerabilities. There are specific guidelines about how quickly you need to disclose. The timeline to like a patch or a fix can be a little more dependent on the context. But it's like a go-to, you generally want to disclose in like a month, and you want to be able to have some kind of workaround of patch within about 2 months. Again, context can make that variable, but whatever process you have when it comes to thinking about how you're updating your SBOM, do think about, if a vulnerability comes out and we need to make a change, right? Is that going to fall into my regular update cycle? or is it going to fall outside of that update cycle? And how am I going to handle that?
So why is this hard, right? Why should this be any harder than how you normally develop software? One of the hardest things, right, is the regulatory complexity. So as you have a device, typically it could be in multiple markets, you can have to meet multiple regulatory needs. And this can mean having documentation to support various regulators. So having the requirements be addressed for what that regulator wants can be slightly more difficult. As Joby alluded to in terms of timeline, metrics is a big focus for the US with the FDA, and they want to see lots of metrics around what's happening with SBOM management and remediation. So that can be a little bit different than what the EU MDR is looking for. The next bit, we kind of alluded to this, right? Multidisciplinary. You really have a lot of folks with vested interest in vulnerability management that can have differing opinions and different prioritizations, and that can make this harder to do. One of the old anecdotes we used to have, right, is you have an engineer working on a device and you're telling them there's a vulnerability. That the trade-off can be, I have a 2-week sprint. Do you want me to fix this vulnerability, or do you want this clinical functionality? And the folks selling the device can have a very different opinion than the folks responsible for the security posture, and that can sometimes be at odds with what the business needs are. Traceability and continuous monitoring, right? These are kind of related to each other. Knowing which version is out there and having clear granularity in terms of what is actually in a device can make your monitoring process or break it, right? If you aren't really at a level where you can clearly track which version of an SBOM is in the field and which ones are already applied or updates have been applied and no longer relevant, that can change how you monitor dramatically. And knowing the risks associated with it are one of the parts of keeping track of those versions as well. Anything, Joby, you'd say? Yeah.
Yeah, I just want to sort of double emphasize the multidisciplinary and really multi-departmental aspect of SBOMs. You'll usually have a relatively smaller team that's maintaining these SBOMs, but they frequently won't have all the knowledge they need in order to even just make sure the SBOMs are generated and fully enriched with all the NTIA minimum elements and stuff that the regulators want information-wise. To give you an example of where the cross-departmental communication can be really important, I was working with one customer. They had a Ubuntu Linux SBOM. Ubuntu comes with Vim pre-installed on it. Vim has a ton of vulnerabilities. Nobody was using Vim. The simplest solution was just to remove it entirely from the device. It dealt with all those vulnerabilities. They didn't have to try and secure the system or stop a potential user from accidentally using Vim. But it took a month to do that because they didn't have a good communication channel with the engineers. So when you're thinking about this multi-departmental process, don't just think about it in terms of responding to vulnerabilities. Think about it in terms of the people maintaining your SBOMs need to be able to reach out to, engineers or people in the know about specific questions so that they can resolve those a lot quicker. Otherwise, you can waste a lot of time and kind of run in place.
You want to talk a little bit about legacy, Joby?
About what? Legacy? Yes, sure. So the one thing I do want to point out is that if your device is officially a legacy device, right? Like you've informed all of your users that you're no longer maintaining or supporting it. That's a better situation to be in than the sort of pseudo legacy where it's basically a legacy device, but you need to still maintain it because that second category still has all the same requirements and guidelines that you need to meet for a brand new device. And that can be a really big challenge. I've worked with a lot of customers who don't have access to source code. They've just got the binaries that were built from it. I've got a lot of customers who are working on older embedded devices, like older versions of QNX and stuff like that. And to put it in the context here, we've actually, we've spoken with the developers at QNX, and I don't think there's actually anybody on earth who knows all of the software that comes installed on QNX, right? It's just, it's gone through so many ships, and the people who built stuff back in the day that's still being used today aren't around anymore. It wasn't well documented. The whole SBOM requirements weren't a thing back then. Luckily, the FDA does understand this, right? They know that you can't get everything a lot of the times. What they want is a best effort. And what I try to really emphasize to the medical device manufacturers that I work with is you can put in a lot of work, particularly manually, searching through this stuff to try and identify all the pieces of software that need to be in your SBOM. But what's really more important to the FDA is that you have a process to deal with these legacy devices, right? That might mean that, the first time you generate an SBOM, it's going to involve a lot of, a team of engineers going through and manually sifting through stuff, right? We've helped customers do that before. You might not be able to use a tool to automatically generate stuff. But from there, so long as you've got a good system in place for keeping track of what updates are made to it, right? You don't need to go back and repeat all of that manual work the first time, or the second time, and the third time, and so forth. So while you definitely can put in a lot of time and effort getting an SBOM from an old legacy system, right, FDA ready, what's going to really be more valuable both for you in the long term and to the FDA reviewer so that they can see it is clearly outlining the process for how you come about generating these SBOMs. And like I said, for a lot of these systems, that involves a lot of manual work. It involves a lot of reaching out to different people and asking questions because you just don't know about certain pieces of software. Like, is this a dev tool or is this actually being used in production? In some cases, right, teams have put together tests to try and figure out the answers to those questions because nobody knew. But so long as you've got a process that documents all of this stuff, records it, and makes it so that you're not repeating yourself, and you can show that to the FDA, that's really going to present to them a much better idea of, okay, they can handle this device, right? They're aware of the security implications, right? They've done their threat modeling, they've done their digging into it, right? Maybe there's stuff that they're missing here, but if it arises in the future, I can see that their process can deal with it. And that's really the key.
Yeah, I think legacy tends to be a polarizing topic for folks, right? And so I think that the reality of what you're seeing in on the ground makes a big difference in terms of understanding context here. So the FDA's expectations, right? I don't have one here that I think speaks to the specific guidance and what it's asking for, but at its highest, I think these 5 areas are really what they're asking for. To Joby's point, they're asking for best effort, right? Making sure that you're really putting out what is a reasonable level of effort and what is kind of commercially doable with what you're running. And so having a process, having the various folks involved in this. I think when we think about security, it can often be, hey, I need a tool to solve this process. In fact, post-market vigilance has a lot more to do with process than it does to do with specific tooling, right? With the right tool, the process can be made easier, 100%. But if you don't have the process, the tool kind of, it sits in isolation, doesn't really give you the value you need. And I think probably the biggest thing I would underline here is that collaboration and making sure that you engage with folks around the device. And so if your device is sitting out on eBay and folks are buying it and it's showing up getting hacked every year by researchers, you should probably build a relationship with that researcher community so that you can have a better process for how you manage that and not have a knee-jerk reaction every time something comes through. Joby, I don't know if you've seen any recent deficiencies that you would like to share around post-market vigilance.
I think when it comes to deficiencies, both post and pre-market, the big one that I've seen this year is, and you reference on another slide, but you also reference it here, is the sort of level of support and the end of life or end of support dates for specific pieces of software. I think we're at 5 different customers or 6 different customers so far this year that have come to us specifically with that deficiency. A big part of that is the guidance is not very clear on what exactly you're supposed to do with that. So that is to a certain extent on the FDA. But at its core, what the goal of tracking this information is really about is the FDA had a lot of different customers, medical device manufacturers, who came to them with devices that were running outdated OSs. And I'm not talking like Windows 7, I'm talking like Windows CE, right? And they didn't provide a significant list of vulnerabilities associated. They're just like, it's good. And the FDA was not happy with that at all. So the push to have MDMs and others track this information is really about trying to make sure that they're not using software that won't be patched, right? The biggest issue with unmaintained software isn't even just that, like, if a new vulnerability comes out, nobody's going to patch it. It's that if a new vulnerability comes out, nobody's probably going to know about it unless it ends up in a major hack. And the only real solution to that is to force MDMs to dig into this. It's tough to do. And in a lot of situations, you've got a ton of open source software where, unlike proprietary software, nobody's just going to come out and say, we're not maintaining this anymore. It's legacy software. They might do that, but a lot of the times they're not. So what we recommended, for example, with customers, although I want to stress this, the FDA guidance, again, is very limited on this. It doesn't explicitly say one way or another what your process needs to be. But we've gotten all of our customers through the FDA by telling them basically, look at the open source software, look at how recent and how frequent the updates are, right? If you could find like a source code repository, it's actually possible to automate this process. But you can come up with a sort of threshold, right? If this software hasn't been updated in more than a year, we're going to treat this software as being unmaintained, right? And then once it's unmaintained, what are you going to do about it? Are you going to replace it? Are you going to look to see, well, can I downgrade to a version that doesn't have any vulnerabilities? And there's even the option to, assuming it's realistic, take over maintaining the software yourselves and treat it as first-party software. None of those options are necessarily quick and easy. And again, going back to that timeline of like, how long do you have until you disclose a vulnerability? How long until you put out a workaround, right? If you're doing this stuff only after a vulnerability has been brought to your attention, you can be forced to do this on a very tight timeline. So ideally, you'll take care of as much of this stuff as you can pre-market. But once you're in post-market, if you know ahead of time that something's going to go out of life or end of service, really you want to make sure that you've taken the steps to assess the risk, do a threat model that specifically looks at how are we using this piece of software, right? If we're just using it to log non-sensitive data, we probably don't need to replace it right away, right? We could probably continue to use it. If it's something you're using for encryption, right, you should probably replace it before it reaches that end of life date, right? And that context can really matter, but the key thing again is you want to describe this process to the FDA. You want to make sure that they're looking at this and they're like, yes, that sounds reasonable. Yes, that fits into, the QMS part of your, how you're going to disclose vulnerabilities, right? That's really what they're looking for. And that's really the key that this data point is supposed to drive you towards. Again, people are working on ways to automate this. It's still, unfortunately, way more manual than we'd like it to be. But, we've used through partnerships with groups like TideLift or with ecosystems or stuff like that, there are good ways to automate this so long as you have some predefined threshold, like a year or something that you're looking for in terms of how recently was this updated, how frequently was this updated, or how many contributors did this project have over the last year. You can use any of those if you want as benchmarks.
So one of the things to think about, right, is you most likely have a tool of some sort for vulnerability scanning. Thinking about how the SBOM and the vulnerability scanning tools should work together, I think is one of those potential levers to make this a little bit more automated and a little less manual. One of the core things we see from folks is the contextualization that Joby alluded to with how a lot of vulnerabilities apply to how a component has been implemented in a device can really change how you think about the impact of that vulnerability. So ways to leverage data that is available in the SBOM to inform your criticality rating of a vulnerability, I think is critical to how we think about this in terms of automating some of it. And one of the biggest things we found with our solution and our view of the world is that vulnerability matching and component naming is really an area where a lot of tooling can help and make this significantly easier. Joby alluded to QNX. QNX is a great example of naming conventions just gone awry, where there are so many versions out there for even a single version of QNX that it can make it really hard to know if a device is impacted or a library is impacted. And I think that that's just one example of kind of countless how naming conventions can really challenge the integrity of matching.
Yeah, one thing I would definitely encourage is your engineering team should ideally have some way of testing whether or not, if, for example, if you're using a library, if the library calls can be traced back to specific functions or files, because a lot of the times the CVEs and the vulnerabilities, security advisors, they'll talk about a specific effective function. or specific affected file. So having a process to trace that back for all the libraries that you're using can really help you to speed up that triaging process. It won't always help. Some of these vulnerabilities just don't have as much data as you'd like. Is a last case resort. We have worked with customers who have just reached out to Microsoft about certain CVEs and said like, hey, there's like no information on this. What are we supposed to do about this, right? Microsoft doesn't always get back to them, but they can go to the FDA and they can show like, look, we've done everything we can. Again, the FDA understands that this is a messy and complicated process. What's key is that you have something that you can do, that you can repeat for different vulnerabilities, and that in those edge cases, right, you do just try something just to show that you're putting in the effort.
So I think the next bit here really is talking about how the SBOM can inform kind of what you perceive as a risk posture, right? So I think a lot of folks think of it as only post-market. I think there's definitely a pre-market angle to this as well, where you can use it as part of your internal development process and the way you do quality checks, or you're checking for any vulnerabilities as part of device development and testing. Mitigations, right? We don't patch everything, we patch certain things based on whatever criteria. Having a plan for how you do that, right? Are you going to have separate security updates? Or are you going to have that be bundled when you do regular software updates? And making sure your customers understand this. I think to Joby's point, right? The expectation is that folks just want a level of communication to understand what is happening. I don't think anyone has an expectation of perfection here, customers or regulators. And making sure that kind of best effort is put forth is part of that communication success.
I would agree. Actually, one of the interesting pre-market scenarios I ran into with one customer, they had a device. It was running, get which version of Ubuntu now it was running, but they put it into our tool Helm. We shared the vulnerabilities with them, and they had, I want to say it was like 1,200 vulnerabilities. Almost 400 of them were CVEs with like a higher critical severity score. And they were just like, we don't have the resources to deal with this. So we looked into, well, maybe we want to try upgrading the Ubuntu to a later version. So rather than having to do that first, right, they could just fake an SBOM. And we did like, I think 6 or 10 different versions of Ubuntu that they could look into upgrading to see what exactly the difference would have an impact on in terms of what they would need to deal with. We got that list down to about 400, I want to say, with less than 100 in the high and critical range. And so that was feasible for them to do. And then the upgrade to Ubuntu wasn't relatively all that complicated, but it saved them a bunch of time looking into vulnerabilities that they really didn't need to deal with, just to kind of, get to that core solution first. So definitely can give you an insight before you even use something about what's going to be the regulatory requirement side here from a vulnerability or a cybersecurity perspective.
Windows is like another great example, right? With all the patching that happens there, knowing which patches can have the biggest impact and what you should and shouldn't. And I think that if you were trying to patch every week on a medical device, I think that that's a really high burden to try to carry. And there's ways to be a bit more efficient about it.
Yeah, I would, whatever your upgrade path is, if you know it ahead of time, I would always recommend looking to see what the impact is going to be on your vulnerabilities and stuff like that. Just because it gives you that preparation, right? If you know that a particular version, like you've got 3 versions ahead, you figure you're going to upgrade to this one, then to this one, then to this one. If you've got the fortunate situation to know that ahead of time, you can prepare for it, and that can save you a lot of trouble versus trying to, a month or 2 before this goes live, or if you're doing a submission before you release the product, right? If you want as broad of a deadline as you can get on that SUGS, because especially with operating systems or any device that's running an operating system, you're going to see a lot of vulnerabilities. That doesn't mean they're all going to impact you. But again, the FDA is going to expect you to have looked into them. And that's where the time consumption really comes in.
One of the great things that can be done is using SBOM data to really contextualize and, I don't want to say dismiss, but resolve multiple findings in one shot, right? So there's kind of a few areas where you can think about whether there's data in your SBOM that can really make it more efficient. So getting from 1200 to 100 and knowing that you are in fact looking at what is most important and most impactful. I think that's one of the hardest things in security in general, right? Is there's so much noise, you can sometimes lose the signal. And we think that there are absolute data points in an SBOM that can help change that and really help you focus on the so what area and fix what actually matters, right? And reduce a lot of kind of the fatigue that is often faced in security.
Mhm. And you mentioned here, this slide mentioned CVSS scores, but one of the real valuable things you can do with CVSS scores, and the FDA accepts this because they accept that the standard is a basis for action, is you can actually rescore them. That's really useful in a hospital environment that has, if a device has a limited network access. Most CVEs are scored with the assumption that like the hacker can access your device over the internet. And while nothing is going to change that score to a 0, right? That's not how the CVSS scoring system works. It can move it from a category of a high or a critical to a medium or a low. And that can be really useful because the FDA, one, if you've got a low vulnerability, you can go to the FDA or other regulators and say, we're not going to devote the resources to look into these. For medium vulnerabilities, I wouldn't go quite that far, but you don't necessarily need to have looked at them by the time you've done a submission or by the time you've released the device. You can say that, as long as we've got this process in place, we've shown that we've remediated all of the critical and the high CVEs or CVSS scores. We're going to look into these other ones later, right? You've shown your process works. These ones aren't quite as severe. You can deal with them as needed or as they arise, right? That's a real big value in using a score like CVSS. Another thing too, kind of not mentioned here, but something that, at MedCrypt we're very focused on is, how can we utilize stuff like LLMs to surface more data to people? One of the things that LLMs do really well is to read a whole bunch of text and then summarize it for you, or to find specific quotes or mentions of stuff, right? And we've done this to try and provide users with upgrade recommendations or mitigations to specific vulnerabilities. We're working on a process to try and help to supply a broader list of kind of like tags for the tech stack, stuff like Python. Are you using AWS? Are you using Windows? Just to try and surface more data to people to make that triage process go quicker, because that is where the bulk of your resources are going to be spent when it comes to looking through these vulnerabilities, is figuring out, do they impact me? And if they do, what steps do I need to take to deal with it?
Yeah, I think a good, just broad numbers, right? Order of magnitude. We had a device manufacturer who had an SBOM that they hadn't been actively managing or remediating or anything like that. And I think they started out with almost 10,000 things that had to be resolved in some capacity. And then with rescoring at scale, they were able to get it down to, I think, it was down to in the hundreds, right? And I think that was a much more valuable use of that resource's time. Instead of having a dedicated analyst who was just going through this every day for a year, they were able to put that person to do something else that was also important to the device's security posture.
Yeah, that's also really important. Very few companies, especially the smaller, medium-sized companies, really have a dedicated SBOM team, right? They're wearing multiple hats. So it's the quicker you can make that, the better for everybody.
Yeah. I think Joby kind of alluded to this, but there's a lot that you can do in the automated space around making this a little bit easier for folks to do, right? Integrating into the CI/CD pipeline is huge, and that can make your SBOM management process significantly easier if you have that. Having a central platform for analyzing these things makes it a lot easier when the question gets asked or the FDA calls you and says, hey, are we impacted by log4j? You can answer that question relatively quickly, right? And having a way to generate documentation for your quality management system is another huge kind of time saver that we've seen in terms of automation, in terms of where is best applied.
And especially another area too, you kind of mentioned in that last bullet point, but enriching SBOMs with additional data. Pearls and CPEs are one of the main ways that we do that with SBOMs. There are others as well. But the FDA expects you to have not just the list of vulnerabilities and the name of the code, they want the supplier, right? They want to make sure everything's got a version. They want to know, does this have a license? What kind of a relationship between these components? Like, are these dependent on other ones? Are they transitive dependencies, right? So there's a lot of additional data that isn't going to necessarily be picked up when you auto-generate the SBOM a lot of the times. So being able to enrich the SBOM post-generation to meet those guidelines is also really valuable. And it can save a lot of time when you can automate it.
I think this is just more of an application of how the SBOM can help if you have a vulnerability that you're trying to manage, right? I don't know that I think all these have been kind of discussed at different points, but the critical thing, and I think Joby's alluded to this, right, is that you have a lot of data available in an SBOM that can change dramatically how you deal with a vulnerability and really allow a device maker to move significantly faster than perhaps they could if they were trying to do this manually.
Yeah, and to be a bit of a bummer here, I do want to bring up that, again, it's a mostly automated system. There are particular devices and scenarios where the best solution is just to do it manually. And I know people will spend a lot of time trying to dig into, well, can I automate this? But usually you can't. I'll give you an example here, right? A lot of embedded systems, I mentioned QNX earlier, but also older systems, right? Like languages like C and C++ are everywhere. And they don't really have like the big package platforms like NPM or PyPy for those higher level languages. And a lot of automated tools rely on those package managers to get most of their data. So in a C, C++ scenario, maybe you're using something like CMake that can make it a little bit easier. But in certain circumstances, the solution is going to be to sit down with someone who's engineered this stuff, who knows what libraries are being used, document it all, and then make sure that you've got that master document actively maintained as changes are made. Right? That's really what's going to be necessary for certain devices, especially older legacy devices.
Oh, perfect timing. End of life.
I did kind of talk about this earlier, but again, it's something that is an evolving requirement at the FDA. When they first released the guidance, the reason that they put a single sentence about this, I think one sentence for level of support, one sentence for the end of life date. It wasn't initially mandatory, right? They weren't initially, when the guidance came out, giving people deficiencies for a lack of this data. So some people did get through without that. However, they've become much stricter on the enforcement of this, and I do expect them to update or expand on exactly what the guidance requirement is to make it clearer for people who are doing submissions in the future. But again, it's all about that fact that, when you have people releasing devices with outdated operating systems, you're really risking, not just a loss of information, but really patient safety too. So expect this to become more strict in the future, but hopefully better documented as well, and clearer about what the FDA is looking for.
So in software development lifecycle, I think we've kind of beaten this up, right? It's at all facets of development that you really got to think about where the SBOM should be impacted. Each of these boxes kind of has some detail around it in terms of how you should consider the SBOM at that step. But I think that hopefully this dispels the notion of one and done, right? You really have to keep the SBOM continually maintained throughout the development lifecycle.
And afterwards, I mean, the vulnerabilities are changing too. It's not just the component side of that equation.
Yeah, 100%. And then I think that speaks to the QMS here, right? You having it marry into a quality management system is equally important. All folks at device makers are driven by the quality management system, right? We all know you don't proceed until you've got your documents in. So I think making sure that you're hitting the various parts of the QMS that have to talk about your SBOM process and post-market vigilance is equally important, and making sure you have the documentation to support that over time is certainly a process-driven thing that is not de facto in any QMS I've seen today. Great. I think that brings us to the end here. If you have any questions, don't hesitate to drop them in the chat. As I said, we'll share out the recording, the slides, as well as our emails if you ever want to reach out with any questions you have as you work through your SBOM lifecycle. And I believe the next session will be in 2 weeks from now, and I think it is focused on regulatory details. So I'll give it a second if folks have any questions. But otherwise,
there was a
Toby,
couple
thank you
there.
for joining. I appreciate you participating this round.
Thank you.
Yeah.
Happy to be here.
All right, everyone, keep well, and we will be in touch soon. Take care.